All right, I got 2 viewers now. Aha. Hi there.
Hello.
And you're in the chat too. Nice headphones.
Yeah, I know.
I've had these about 15 years.
Yeah, I've had these for a little while. Where's that coming from? Okay.
So which link worked for you, the shorter one or the longer one?
I just clicked the longer one. I didn't even bother with the first one.
The shorter one is the one I get on the screen where it just says, show me links to this event. And the longer one is the one I get actually in my URL bar.
So the longer one is just a stream.
And the shorter one is to the event page.
Sorry, the shorter one's to the event page, and you can't actually do a hangout with that.
Oh.
Yeah.
So what use is that?
I don't know.
So with the event, do you get a round button with a start in it, or do you get a blue button with a start in it? You never looked at the event, so.
So I'm looking at the event right now, and it's just the Google Plus page with your profile and a YouTube box, and that's it.
Hmm. Let's see. Share event. It was made public.
Yeah, it's public.
Yeah.
I mean, I can.
Well, this would be a message for Chuck then. Try the longer link.
So this is what the first page looks like, or the event page looks like. Let's see if I can make this a little bigger.
I see. So it's just a YouTube.
So it's just your output.
Yeah. Although now we see another screen from you. Well, I guess we'll have to proceed.
Can you hear my video or my audio? Sorry.
Yep.
Okay.
So Chuck, you used the longer link?
I did use a longer link, yes.
Yeah, okay. So I'm not quite sure what the purpose of the shorter one is, except to just give you a way to get to watch it on YouTube, but not actually to get into the Hangout itself. All right, then. Well, we got to move on here. All right, so I'm going to... So what? Let's see. I think from the control panel I can mute you guys. Or you can mute yourselves, and then if you want to ask a question, then you can unmute yourselves. There we go. Okay. So we've got a couple of people watching on YouTube directly, and we got a couple of people that are in the Hangout. And I'm not sure how to get people who don't have access to the discussion forum where I posted the link, how to get them the link. Except maybe I can post it on the event page. Try that. Let me get that link again. Okay, I posted a link on the event page, so you should be able to click on it and get into this Hangout. Okay, so when we left, say again?
There's quite a long delay between our Hangout and what they're seeing on YouTube as well.
Who's more delayed?
While we were talking, there was silence, and then I had I had it through the YouTube as well, and it was probably about.
It's a 30-second delay.
Yeah, about a minute, I guess. Yeah.
Okay.
Yeah, Google implements a 30-second delay between YouTube and Hangout, or between your Hangout and the YouTube stream.
All right. So they're about 30 seconds behind. Okay, anyway, so we'll pick up where we left off. So we're writing a simple network server in C, and I've never done this before. So what you'll see is, I mean, I have done it before, but it's a long, long time ago. And so what you'll see is me making all sorts of mistakes.
Okay.
Trying to do this. If you have joined in on the Hangout, you'll want to mute your microphone unless you're talking. Otherwise, it pops up over everyone else's. There we go.
Okay, anyways, we'll pick up where we left off. So we're writing a...
Thank you. Okay, so we have a main here. We've created a socket, and then we set the address, and now we need to bind. So that is so result equals bind. So we're going to bind this socket to, and then it's going to be to our server address. So we would say serve adder like this, but I think that's not going to work. Serve adder, because I think it's going to complain about types. So let's go make, yep, let's see. So it is expecting a struct sock adder pointer.
Yeah, Barry, you're muted right now.
There we go. Sorry. All right, so we got a compile error because server address is a sock adder in, and bind is expecting just a sock adder, because there are many different types of sockets you can create. An internet one is just one of many. So we're going to go a sock adder pointer. And I think we need to say struct here. And good. We just got a warning about unused variable, and that's fine. So we'll say if res is less than 0, then we've got an error. Good. So excellent. So now we bind, and now we listen for a connection. So we say listen. Let's see. So what we do is we say listen for a connection. So this basically pauses the program at this point, and it's going to wait for a connection to come in. The 5 here is how many like outstanding connections will allow. I'm following an example. It says 5. I'm sure we can make this number bigger, but I don't see any reason to. So this means that while it's processing one connection, there could be 5 other incoming connections that are waiting in queue to be picked up. Once we get past the listen, we are then going to accept the connection. And so what happens is when we accept the connection, it's actually going to assign a new socket number to us. And the reason why it does this is so that you can accept new connections after you accept one. So in other words, if a connection came in and it used the same socket number that was being used to create the socket, then you could only accept one connection because you'd have only one communication channel going across that particular socket. So what happens when you accept it is you get a new socket number, and then the old one can be recycled to be used again. So we'll say, let's call this like a new socket file descriptor. And am I muted again?
You've got a hotkey that you're muting yourself with.
And I think it seems like anybody can mute anybody.
Apparently.
So
people may be muting me.
yeah.
Let's see, I can mute other people, but I don't see how to prevent someone from muting me. So after we accept the connection, then what we're going to get from this accept is the address of the client who connected to us. So we need another variable here. And I guess this is size of client address. Socket length T, address length. All right. Interesting. I guess what it needs here is it actually needs a pointer to an integer. So we'll go integer client.
Yeah, Barry, you've definitely got a hotkey that mutes yourself.
Really? Am I cutting in and out?
It's actually muting yourself in and out while you type. So yeah, you're cutting in and out, but you can also see the mute and unmute happening while you type.
I'll try to keep an eye on it. So you're saying when I'm typing, it's muting. Now the problem is I don't see the status of my microphone unless the cursor is actually on that screen, and so I can't move it back and forth very well. Oh, so I need. All right. Funny, I don't see my chat saying that I'm actually muting. Or not my chat, my window.
I don't think it's a Google Plus mute. I think it's a hardware mute. Like your microphone is turning off and on.
It could be some kind of noise cancellation type of thing.
So you hear me talking. So when I talk, is it a continuous sound that you hear?
Yes.
Okay, but my typing makes it like click on and off.
Yes.
All right, so that is actually a noise canceling thing.
It does cancel
So
you talking sometimes, though.
do you like just miss the very beginning of what I say, or is it like while I'm typing, it's cutting on in and out as I'm talking?
It's cutting in and out while you're talking, and then I don't know, it just stops working sometimes too. So don't really
All
know
right,
what to
that's
say.
weird. That's weird. It's not a simple setup I have here. Let's see if I can. This is going to look a little weird, but USB interface, mixer, and then back there is microphone preamps and audio compressors. So, and did this cutting in and out happen the first time we had the Hangout?
No, it didn't. But just start typing again, and I'll tell you when you cut it in and out.
All right. Where were we? Oh, so find a socket, accept connection, then hand off to functions. So let's call this as do yo, I guess. And then we're done. Exit. And then I need a function that'll do that. Void. call it sock. Let's go F right. Oh, what's the manual page for that? F right. F right. Void pointer, size, file pointer. Nope, 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 nope. Oh, I want to use send. Send. All right. String copy into the buffer. Got it. Okay, send needs a socket number, pointer to the buffer, how long the buffer is, and some flags. So what do we say? Socket number and pointer to the buffer and how long it is. Zero. All right. So let's make a new window here. And we'll go NC 173.255.244.177.123.4, and it says got it. So I just made a connection from my computer to the server, and the server sent me a got it. So if we watch this again, I'll run the server. Oh, can't bind a socket. Why not? Okay, that's interesting. That and nothing's listening to that socket. So we want to find out why this is not working. And unfortunately, our message doesn't tell us anything. So the answer there is to get it to tell us something. So let's put in a string here. And there is, I believe, a function called p_error. And there's this global variable called error_no that tells you what happened with the last thing you tried to do. Error_no.h. So we get an integer variable called error_no that contains errors from the last system call. And I included that. Argument type void is incomplete. Okay, man, Pierre. Oh, it's a string, I see. Okay, well, I think the thing to do here is I'm not sure what happens there. Make. Ah. Oh, so I think P error just P error. Can't happens there. All right. Oh, now it's working. Okay, it didn't say got it. Why not? Address already in use. By whom? Oh, you know, after I said got it, I need to go close new sock FD and FD. Close comes from Unistandard. Okay, so the reason why we get address already in use is I didn't close the sockets, so the operating system kind of keeps them reserved for a while, and then eventually they're going to time out. But it takes about, I think, 2 minutes for that to happen. There it goes. Okay, so I got it here, and then this returns. And can I run it right away? Ah, I can't. Address already in use.
It takes longer than 2 minutes for a socket to expire.
But after my program quits, it should close the sockets. Let's go netstat-an grep1234. Yeah, okay, so it's in time wait state, meaning it's waiting for any packets that might yet come in to come in. So this is maybe where I go shorten time wait. Between 1 and 4 minutes. Lovely. So I guess the program itself can't shorten its own time wait. Yeah. All right, so I guess it just means we can't run it that often. All right, so in the do-yo function, now that we know this works, can I use a socket that's already open? No. So once the socket has been created, then that's it. No one else can use that one. Okay, but so in this do-yo function here, now that I've got a socket number, I can start implementing the protocol itself. So I need to I will go string copy into the buffer. What error code should I use? 250? Something like that. And then we'll go send over the socket, buffer, string length buffer, And then now we're going to wait for input from user. So I'm just going to do a receive at this point. Receive, socket, in. I need to know all the, and receive. This is the total maximum length, so 1,000, and then flags. And so now that I've got, okay, so is my microphone still cutting in and out?
It's still cutting out a little bit, but you're not getting muted for a long time anymore.
I didn't change anything. You think it's the noise cancellation? Probably. I just need to tweak the settings on that, all those stuff back there. Alternatively, I can just completely turn it off, and then you can hear everything that's going on here. Let me see what happens if I just completely turn it off. How's that? Actually, let me turn it back on, and I'll just press one additional button over there. Okay, that was something that I changed like earlier today. So let me know if that's better. Okay, so wait for input from the user. So we're waiting for the me is. I'm looking at my notes here. We're waiting for the me is. So what I want is kind of like this thing is going to go into a loop where it is waiting for input from the user and then acting on it. So I'm going to have a kind of a state machine going here. Let's go integer. So let's make some constants here. This is not authenticated is 0. And so basically, if they haven't told us who they are, then there's nothing else they can do. It's just going to keep asking them to log in over and over again. Once they do tell us who they are, then they can start doing the other things like listing all the users, exiting. Actually, they can exit anytime they want. They can collect the. Actually, let's do that. Let's implement the they can exit anytime. So you're saying this is actually better. All right. So I'll remember to keep that button pressed over there. Okay. So we're just going to go into this kind of infinite loop here. Wait for input from the user, and we'll do like a if string compare. What is the exit? Oh, no yo. Buff. I'm using the n compare function here. This n compare means it will compare at most n characters, where n is 1,000 here, and this keeps the string compare from potentially going off the end of the buffer, going off the end if in fact the buffer got completely filled and there's no null character sitting at the end of it. Because the thing is that these buffers are just arrays of characters. They're not strings. They're just arrays of characters. So you get a bunch of stuff from the client, and it's not null terminated because this is, I mean, because the client doesn't know about C strings. It just sends a bunch of characters. So if I use string n compare, then I'll make sure that I only compare at most 1,000 characters, and I'm not going to run off the end of the buffer and start comparing stuff that's in memory. So if this returns 0, then it means that was a. Wait, let's make this 4. All right, so we're just going to look at the first 4 characters. If it's that, then we're out of here. return, I guess. What we need to do is we need to say close socket and then return, and then we're done. So let's see if that works. Unused variable, okay. And over here, can I move that? Let's see, if I move that there, you can see it. If I move that and see it. There, this way. It's just peeking out underneath this window and I can click on it. There. Okay. Oh, yo. Exit. Cool. Now, of course, it's not going to work again. So we got to wait. Okay, so that means my exit works. So now let's go else if me is let's do it this way. Buff. So what I want to do is there's a command, and then the command is going to be me is, so they're greeting themselves. Me is, and then a username. I wonder if we can just do it like this. We'll see if it works. So I need a oh, I know how I'm going to do this. I know how I'm going to do this. Let's go. Not string and compare. Me is buffer 4. So if the first are me is, then I can go character pointer username equals buff plus 5, I think. So we're going to point 5 characters into the string, and that'll be where the username is sitting. And then let's just get our program to print out that username. User is %s username. All right. Joe. User is Joe. Hello. Okay. Where did this come from? Oh, wait, hello. Oh, that comes from here. Oh, it's because we're reusing this buffer. Okay, so we're reusing the buffer. So we can't just like point 5 characters in there. We'll have to use something like, oh, okay, so we'll do it this way. Character username scanf buff plus percent user. All right. Oh, no yo. Boom, out of there. Okay, so what we're doing here is we're using the same buffer to both receive and send. So I put this 250 yo hello into the buffer and I sent it. And then I wait for input to come back from the user. It puts it into so the person types in me is Joe. It puts in those 8 characters into the buffer. But again, they're not null terminated or anything like that. It's just 8 characters that get dropped into this character array. So there is going to be a new line sitting at the end of there because I typed a new line when I was over on this window here. So this should work because this %s is going to pick up the string and it's going to stop when it hits that new line character. What I was doing before of just printing out the buffer was it just going to go until it hits a null character, and there's not even really guaranteed to be any null characters anywhere in that buffer. Again, they're not strings, they're just arrays of characters. So I think this is going to work better. Let's see if, okay, there we go. And then we'll connect, and then we'll go me is Joe. And there we go, user is Joe. Excellent. And then I can go no yo, and then I'm out of there. All right. So if I got the username, I now need to acknowledge that to the client. So send back confirmation. So that'll be like a 200 code. I don't know what. Let's just use 200. 200 logged in. And then we'll send it. Send socket buffer string length. Now in this case, I can use string length because I'm using string copy, and so this is an actual C string that I'm sending there. But I'm not going to send the null character to the other side because I'm only doing the length of the string without the null character. So this is okay to do. Okay, me is Joe. Good, got it logged in. And then no yo, out of there. Good. Somebody sent a link to Stack Overflow socket connection timeout. Put the socket in non-blocking mode until you've connected. All right, I'll take a look at that later if you don't mind. That'll be like version 2. Ultimately, this program is not going to quit so early. It's going to accept a connection, and then once the client connects, it's going to allow another connection to come in. So I'm not going to be too concerned about waiting for the timeout. And it looks like the timeout is only about a minute on this anyway. So we'll look at that link a little bit later. Okay, so now we'll go else if string compare. Should we do the list all? So this is handling the list all, and then we'll go else if, let's just get them all in there. And finally, send string copy. Let's see, not logged in. That'd be like a 500 code. Send. So the user types in something that's not recognized. So if I type in blah, it says not logged in. Oh, sorry, this is not if they're not logged in. This is like command not recognized. So command not recognized. No. Oh, yo. All right. So this is list. Let's just get it to print out something right now. Just want to make sure that and then this is going to be send Q E yo. Yo queued. And then what was this one? I'll collect them. Okay, let's try it. Nice. Joe, all right. And then Yola. There he goes. Good. 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 Yes, sir. All users. Okay. That's something to take care of. Is you can log in twice. I don't know if that would necessarily be a bad thing. Eventually, we're going to have to put in. So if they logged in, then we'll say state equals logged in. So all of these other commands are first going to have to check the state, and if the state is not, the state is still 0, then it needs to print out an error message to say they're not logged in, and then go back. So I guess we'll do that here. If complain. character buff. So string copy buff 500. And then send it. Send socket buff string length. And then that's it. So the only purpose of complain is just to say they're not logged in. All right, see how it's doing here. Yeah, gotta wait. Let's see, what can we do while we're waiting? If not state. Complain. Return. If not state. Oops. Not logged in. Oh, it exited. I'm not supposed to return. I'm just supposed to complain. Ah. Okay. So we wanted to do listing all the users. Version 2. Yeah, there will be no version 2. Okay, so the way all users is going to work is it's going to query the database and just get a list of all the potential users that are on the system, which could stack up quite a bit. Now that I'm thinking about it. Oh, let's make sure this works here. Recognize command. Not logged in, but yo queued. Oh, see, that's why I wanted to reach. Oh, it's not return. It's break. No, not break. Continue. This causes it to break out of the loop and go back up and do it again. Okay. So what we have to do here is we have to query data and display at the end. So this is where I need some help. Man, SQLite 3? No. Okay, SQLite 3 open. Aha. What do I need to include? Can I move my screen out from behind my head? Um, like this? Or like this? Well, I won't be able to click on it then. Okay, I'll move it over here. All right, I'll just have to bring up the terminal a different way rather than clicking on it. Oh, I can also do this. I'll move me. How's that? Okay, I need to know what to pound include. Oh, well, that's easy. Okay, so we're going to send the, before we even send the greeting, we're going to open up the connection to the database. Greeting to the user if we don't have a connection. Okay, so we're going to call SQLite3 open, and what we get back is a database connection object with a, which is a SQLite3 type thing. So SQLite3, let's call it DB equals SQLite3 open. And I think it's just it's a file name and, oh, I see how this works. We get an integer back indicating like whether it worked or not. Pointer. So I guess that means, wait, where was my open connection? Where did I make the variable for that? It's disappeared. Oh, I erased it. Silly me. SQLite 3 pointer DB. Let's try that. Open yo.db and then the address of DB. If this, I guess it's going to return. We can see what it returns. Doesn't say. So I'm going to guess. I'll bet I have to do this. -L SQLite 3. Ah. All right, we got a greeting, which means it was able to establish a connection to the database. So that's good. So we got a database connection open, and then the next thing to do is to prepare a statement. Query database for all users. All right. So we pass it that, we pass it the SQL statement, how long it is, and a statement handle. Pointer to unused portion. Oh, of Z, what? Oh, I see. Okay. I think I see. Okay, so I need a SQLite 3 statement. SQLite 3 statement pointer. And then I'm going to go, what was it? SQLite 3 prepare DB select uname from, I forget what the name of the table is now. Uname from users. And then the address of statement, and then this is a pointer to the unused portion of ZSQL. I wonder if I can just pass in a, yep, I can pass in a null. Excellent. Null. Okay, and then we do step. This routine returns a single column from the current row of a result set for a pairs statement that is being evaluated. Here we go. SQLite column text statement and the column number, which is going to be column 0. And we get back a pointer to character. And then how do we know when we're done? I guess it just probably returns a null when it's all done. All right. Display list of client. So we'll say while, let's go character pointer uname. So while uname equals SQLite 3, what was this? Column text. Column and 0. Does not equal null. string copy, buff, unit, how it goes, and then send buff. No, sorry, socket. Buff. And then send a dot. Send sock. We'll see how it goes. I'm getting nervous. Okay, to prepare. Expected 5, have 4. All right. Oh, I didn't call this. Oh, number of bytes. That comes after the string. Man. Okay, this is the SQL statement. So I need the length of this thing. Character pointer query equals okay. And then assigning to character pointer from constant character. All right, well, we got a different problem here. I shouldn't be using this. I need to be using step. What does it return? It returns an int. What does the int stand for? Goofy interface alert. Should I be using this SQLite 3 prepare version 2? Use of the V2 interface is recommended. All right, prepare version 2. Looks the same. In the legacy interface, I came out when any of the result codes might be returned as well. Oh, all right. All right, so if it's not SQLite done. All right, so while SQLite 3 step statement doesn't equal. All right, so that's going to step through the results from the query. Then we're going to fetch the username. So that would be SQL 3 oh, statement 0. Send. Okay. Make. Expected expression. Well, what's wrong with that? While. Oh. Passing constant unsigned character pointer to parameter type constant character pointer. So I'm doing this one. You should call SQLite column text. First to put results in desired format, then invoke column bytes to find the size of the result. Okay, I'm confused by this. If the result is a UTF-8 string, we change the number of bytes in the string. Oh, because it's not going. Are they saying it's not going to be? It's not going to be null terminated. Strings returned by this, even empty strings are always 0 terminated. Okay. Well, okay, so why doesn't this work? String copy into the buffer, the thing returned by this. But the error was passing constant unsigned character pointer to parameter type constant character pointer. Oh. So string copy expects it to be a signed character, and this is returning an unsigned character. That's what it's complaining about. We could fix it. Character pointer uname unused. Where was it? Here. Me is Joe. Good. What was it? Oh. All right. We got no results. That's actually a good result. So if I go into the database and I go insert into users, new name, values, let's put in a user there. And insert Bob. Two people in there. Oh, I don't have, shoot, I don't have IDs for them. Delete from. default. Joe, let's see, does that work? Nope. Is it null that I have to put there? No. See, this is a serial number, so it's supposed to be automatically incrementing the serial number. All right. So SQLite 3. Should it be auto increment instead of serial? Usually not. Okay, usually not needed. Integer primary key. Okay, uninsert. It's not explicitly given a value. Okay. Okay. So drop table users, create table. Still didn't give me a number there. Well, let me put auto increment in there. Aha, there we go. Good. Hey, there we go. Bob and Joe. We don't get new lines on there, but at least it's working. So let's use sprintf into buffer %s new line. This thing. The other thing to do is every time they log in, we're going to insert their username into the table. So SQLite 3 insert. Does this have like an insert or replace? Excellent. Insert or replace. That makes it easy. Enter. So let's go character. This This is not a good way to do this, but insert. No, this is a terrible, terrible way to do this. Insert into insert or replace user uname. I hate this. %s. Username. So we're going to do the prepare, and then we have to do that step. And I think that should take care of it. Okay. Let's come up with a different name. Arthur. Logged in. Okay, and then what is it? Oh, sir. Oh, darn, it didn't insert. Insert or replace into users, uname values. Okay, there should be the username. Prepare. Query. Statements that do not run on completion. Okay. So yeah, just call step. Oh, is there a step v2? No. So that should be it. Prepare this query, run a step, which will run the query. Let's see. Insert. Or, oh, yeah, I have a syntax error. Should be in. There we go. All right, so I think that's going to work. So when the user identifies themselves, it's automatically going to put them in the database. And then if they list the users, they should at very least see themselves, and they'll probably see some other people. Okay, and this is not going to say all users. Let's say this is going to say like 300 all users, just to tell you that there's more data coming, and it's going to end with a dot. Me is different name, Sue. Okay, there we go. Arthur, Joe, Bob, and Sue. Okay, let's log in again. Barry. There we go. Arthur, Barry, Bob, Joe, Sue. Okay, they're all there. All right, so I think this part is working. We can now list all the users. And now I need to send a yo. So a character query sprintf. Again, this is a terrible, terrible way of doing this. That's one problem with things. These things never get fixed later. Insert into yos. Oh, there's one called the yo from and the yo to. Drop table yo. Create table integer primary user. All right. So insert into yos, yo from to val. Oh, I need to know my own username. So we need to store that somewhere. God, you guys are all going to be crashing this system. I'm going to fix that. Values. %s. %s. Username. Okay, so character 2. scanf buff plus 5. Is that right? No. Wait, how did I do it up here? So I need to extract who it's going to the same way I did it up here. Buff plus 5 %s. Two. Okay, and then SQLite. Good night. See you later. Pair v2. Okay, so I'm committing a big error here, which not an error. This is one big giant function, and I'm having to scroll back and forth, back and forth, back and forth. I need to be breaking this up in a while. Okay, let's see if that took care of it. Okay, me is Bob. All right. This is users, and then if I go, all right. So it says it's queued. The way to find out is select star from, look, there's one from Bob to Barry. Excellent. Okay, so the way it's going to tell you who's got yos for you is the same way we did this. Select yo2 from yos. Let's go order by ID, where yo select yo from yos where yo2 equals %s. Order by, okay, so this needs to be character, and this is going to be an sprintf. Sprintf query username. Okay, so this is going to be who are the yos from, where the person it's to is me, order by ID, so they get chronological order. And then we're going to query it, display list of the client. So we're going to step through there, getting column 0, printing that out, and then sending, okay, good. Oops, Control D, okay, Good. So let's send one to Bob, and let's send one to Joe. Whoops. All right, that's not cool. That's not cool. Oh, I know why. I think I know why. Yeah, we're gonna have to fix the users table to get rid of that problem. Okay, and then no yo. All right, so let's see what we got here. So, all right, from Barry to Bob, Barry to Jen. Okay, see, that's a problem. I don't know why I let that one through. So drop take this. Yes, it will, of course. Create. The reason why it let me drop it is because it doesn't actually enforce these references. I knew I should have used a different database. Okay, so with that done, let's try this again. Okay, me is Bob. User is Bob. Yo, Barry. Yo, Sue. See, it really shouldn't be letting me do this because there is no user called Sue. So I need to verify that there is actually a user called Sue first before I let them queue that up. but I'll have to fix that. So I need to start making a list of stuff I need to fix. So if I now go, so if I go me is, Sue, and then I go YOLO. Here are yous. One from Barry and one from Bob. Excellent. So if I do that again, it's going to say the same thing. What I really need to do is I need to, after saying here are your yos, I need to delete them so that they're no longer in queued. So that would be the next thing. Here are your yos. Okay, so and now I'm going to do another one. Sprintf. And then prepare it. And then step it. And that should do it. I just see this big giant function and I think I need to break that down. Okay, me is Barry. Yo-yo. And then let's identify myself as Bob. Okay, I got 2 from Barry, and then if I do this again, there are none. Excellent. Then if I send one to Barry, it says there are none for me, but if I identify myself as Barry, I get 3 from Bob. All right, so what remains to be done? I need to, okay, so the login I'm pretty sure works. The listing all the users works. Sending a yo for someone, I need to verify that that user already exists. So check. Is there going to be a clear yos for after you? Yes. Actually, it already happens. As soon as you view your yos, they're gone. There is already a delete in there. As soon as you view yours, it'll delete them. You only get one chance to view them. Snap yos. I needed to move this down here because I need to get the username up here. So the first thing we're going to do is go query. And so an easy way to figure out if a user exists is just count the number of users. So since this database does not enforce inserting a row for a user that doesn't exist, unfortunately, we're going to have to check ourselves. So one way to check is to count the number of users who match that username. Select count star from users where and if that number comes out to be 1, then we know that there is a user with that username. If the number is 0, then we know there's not a username with that username. User with that username. Okay. And then we're going to step it. And then we're going to get the column, and that should be an int, probably. So SQLite column int. So this is a statement, and column number 0, int user count. And we'll say if user uh, uh, and then send. And then continue. All right. I need Barry, and then if I go yo-yo black, no, exists. Excellent. So Sue does exist. Does Sue exist? I guess Sue does exist. Okay, this is still interesting why it's continuing to insert the same user over and over again. I'll have to figure that out. So Joe doesn't exist. Good. Insert, replace into insert or replace into database name, column name, values. Insert or replace into users. I'm looking for the documentation on the actual syntax. Here we go. That's what I already saw. Insert, replace. Insert or replace into users values. It should work. So the idea there is that it only inserts them at most once into the table. Maybe we should do insert or fail. Insert or ignore. Okay, me is Barry. And then if I go yo-yo Sue, user doesn't exist. Okay, me is Sue. Now I get Barry. Me is Barry. Dang, still showing up twice.
Can you set up the database to not accept duplicates, and then do something with the error that it will come up with?
Yeah, well, that's what I was hoping this would do. It was this insert would just, if it already exists, it'll throw it away. I guess what I need to do is make the username be a primary key. And then hopefully it'll throw it away then if it already exists. So drop table users, create table uname text primary key. Come on. Come on, I'm gonna test it out.
You could just set it to run off 2 or 3 different sockets.
Well, you kind of only get 1 socket per port. So, of course, it takes a long time to time out when you really want it. There we go. Oops. Okay, me is, let's see if this works again. Logged in. All right, me is, so making that a primary key means that, oops, whoops, that's a problem. Making a primary key means it's only going to appear in there at most once. Okay, so I need to kind of like write down things that this doesn't do. So, to do. No user specified. What's another problem that we have? No user specified. We already got handled with you're trying to send a yo to someone who doesn't exist. Send to, I think that's the only problem right now. So we'll do something like, how are we going to do this? If not str length, username, hmm, 500, no user specified. Send buff. And then continue. So hopefully, if they didn't type in a username, then it'll give us an error message, send that error message, and then we'll go out. So while we're waiting for the socket to free up, I'm going to put in some stuff for me. Well, look here, we can go if not string 2. Get. Okay, me is Barry. Oh, me is ah hmm. Wee, look at that. So it actually is getting a username out of there. You gotta figure out what to do about that. So let's go like yo-yo and then see Barry sending yo to ogged. How do we fix that? I think the answer to that comes from where's my receive? Here we go, receive. Receive is going to tell us how many bytes we got back. So let's make this like 999. You know, int received, and then we'll do this buff plus received equals. Let's null terminate that. There we go. Okay, we get the buffer back from the client, and then we know how many bytes were received. So we're going to put a null there, and that way, if they didn't type anything, there's going to be a null sitting there, and when we do the scanf, there will be no characters to scan. So I think that's good. And then this works, right? Yep, user is Barry. And then let's send one to Sue. Barry is sending yo to Sue. Good. If I go yo-yo without it, it still says queued. Oh, it still says, But that one worked. Oh, wait. Huh. So we get the number of characters, and then we're just going to stick a null there. Am I sticking it in the right place? So if I got me is, and then a new line, I'm going to get 1, 2, 3, 4, 5 characters back. 0, 1, 2, 3, 4. And that should put it in the right spot. 5. Let's go yo-yo. Yo cute. Barry sending yo to Sue. Oh. Is Sue getting all the... And I don't think so. So if I go yo-yo Joe... Oh, do it over here. Yo-yo Joe. No, it doesn't exist. Me is Joe. Me is Barry. Yo-yo. Okay. And then if I go yo-yo, like that, it still says Joe. So I think buffer plus 5. Is this the right number? Does Joe now have 2 yos? Yes. We can verify that if I go no yo, exit out. No, yeah. Oh, over here. Yep, Joe's got 2 from me. So buff plus 5. So if I send yo-yo Joe, this is buff plus 0, plus 1, plus 2, plus 3, plus 4, plus 5. That is the right place to be scanning. Oh. Yeah, so what happened was if no user was specified, this scanf fails immediately, and the value of 2 doesn't change from the previous time that we ran this. So we should clear the buffer. That's a good idea. Yes, we are reusing the buffer over and over again. But instead of clearing the buffer, we could pay attention to how many words scanf was able to retrieve out of there. And if that's not 1, then no user was specified. So let's go int users equals this. So that's what scanf returns. Scanf returns the number of items it was able to successfully scan. So really, a better way to do this is if not users. Let's do the same thing up here. Int count. If not, count. User is. So this is saying that it was able to successfully scan in something. And I think really the problem is we're skipping 5 ahead, but I only typed in 4 things. So really this has gone beyond the end of the buffer. And that's not good. So we shouldn't just skip ahead 5 if in fact the buffer, if there's only like 4 characters in the buffer. Mm-hmm. See, I wonder if we can do something like this. Let's just go buff. And then we'll go me is username like that. Let's just see if that works. So the idea is, instead of skipping ahead 5 characters, we'll just start at the beginning, and the first 4 characters better be this, and then there'll be 0 more space characters, and then there'll be a string sitting after there. Let's try that. While we're waiting, do the same thing down here. Come on. Well, more or less have taken care of that. Just got to debug it. There we go. Ah, didn't work. Me is buffer 4, okay. It must be there's like, see, this is clearly not returning 0. It's returning something other than 0. Can you set user to be not null in database? I think the problem is that it isn't null. It's like a new line character or something. I want to see what scanf is returning from this. And we're going to have to wait a while. So clearly this is not returning 0 like I thought it would. It might be returning 1 because maybe this counts as one thing. And so we want this basically to make sure that this is maybe 2. Come on, any moment now. I wonder if it actually takes longer the more I test it like this. There we go. Okay, scanf returned 1. Scanf returned, returned -1. Oh. So we'll say if count is not equal to 1. So it was returning a -1 because the string terminated early. So it's not that it couldn't successfully scan in anything. It's just there was nothing to scan. It got past the MEIS, and then it said, "Oh, that's it, end of string." So -1. Essentially, that -1, I believe, is the same as end of file, saying there's nothing left. By the way, while we're waiting, I'm wondering, does the video quality okay? Because it looks okay on my end, but the video quality on your end is going to be dependent upon like your bandwidth. So you might get a slightly fuzzy picture, even though I'm sending it as 1080. If it comes in a little fuzzy, then just wait till YouTube processes it, and then you'll get a nice 1080p image that you can watch later. Okay, Barry's logged in. Oh, come on. Scanf returned -1, but did I make? Huh, I did not. I'm an idiot. Now I have to wait. Let's see what else. So there's a serious problem here, and that's all these inserting strings into the SQL statements here. If you write programs like this, this is the problem with doing database queries, is you're essentially what's called programming by printf. You embed a programming language in a string, and then you send that string off to the database. And the problem is that I'm just embedding the string in here from what the user typed in, and I'm not checking to make sure there are not any characters in there that the database might interpret it as being part of the command and not part of the username. For example, if I typed in a username that included a quote mark in it, it would think that the string was stopping early, and then the rest of the command was just this unknown syntax error, which would essentially cause the SQL statement to not work. And so there's this thing called SQL injection attacks, in which you can carefully craft a username to put in there that will cause the database to do something it's not supposed to do, like maybe insert a user in there whose password you know, or automatically, or get you to get a normal user to log in as the administration user. So the thing to do there is to what's called either sanitize the string, which is to remove any special characters or at least escape them so that they're not special anymore, or don't do it this way. And I didn't see a way between prepare and step to do it the right way. Which is in the insert to put in these little placeholders or question marks to say I'm going to insert the values later on, and then you don't have to put them inside of strings. You should read up about SQL injection attacks to see ways of isolating your variables. So they're binding parameters and using prepare statements. Oh, bind. Well, now they tell me. Well, this should be ready to go now. Okay, me is no user specified. Good. Me. Excellent. Yo-yo. Sue. Yo. Yo-yo. No user specified. Yo-yo. User don't exist. Yo-yo space nothing. No user specified. Okay, good. This is working. Me is Sue. What's it? YOLO. Barry, Bob, and a bunch for Barry. And then if I do it again, there are nothing. All right. So I don't want to fix this right now. I want to fix that later, unfortunately. What I want to do right now is get it so that this will accept more than one connection. Right now it only accepts one connection, and then as soon as they hang up, as soon as they quit, then it's done. So the way to do that is to kind of make it almost multi-threaded. A cheap way to do it is you get a connection, and then you do what's called a fork. So the process duplicates itself, and then one process lives on to accept a new connection. The other process processes the query or processes the transaction and then quits. So that's all going to be done up here in main. So after we accept the connection, let's see, we do a listen. Is that right? And then we're going to go into a loop. So we're going to accept handoff. Oh no, not going to hand off. We are going to go integer PID equals fork. So it causes the process to split into two, kind of like an amoeba. Did you say I'm going to keep this in one big function? No, eventually I should break it up. But I'm looking at the time now. It's almost 10 o'clock. And so I kind of want to get at least the sort of version 1 of the program working so that you guys can start at least working on the project tomorrow. And then we'll clean it up later. So we're going to do a fork, and we say if PID is less than 0, that means something happened. P error could not fork. And exit. I'm going to say if PID is equal to 0, so that means I was the child process. This is the. Then we're going to do the handoff. And then we're gonna close the parent's socket. Else this is, then we're going to close new and then we go no, there's no wait. All right. So let's see. Uh-oh. Gotta wait. So I wonder if I can do login integer sock character. Oops. I was hoping that would be able to unshift. Nope. Shift left. Now this is not going to work. There's a lot of cleanup to do here. Okay, so I can establish a connection here. And then let's open a new window. And now I've got two connections going. So I've got logged in as Barry down here, logged in as Sue up here. And then I can say yo Sue, and I can go YOLO up here, and it says there's a yo from me. Send one. Uh-oh. Here are your yos. It didn't say there were any. Let's see. Yo Sue. Did that work? Okay, that one said there's one from me. Okay, that's interesting. Why doesn't it say that there's any for me, but I can send them to Sue? Oh, and it's also not clearing them out. I am looking for complete. Oh, Where's prepare? Prepare version 2. After I see what I'm supposed to do, I'm supposed to do, let's see, what's finalize? Call to delete a prepared statement. Chuck is online now. So what I believe is happening is um, the since I'm not finalizing the statements, I think it's not actually saving what I do. That's my guess. Database connection, so the unfinalized the SQL that will close will leave the database ocean and return. All right. This is the end of my loop here. So SQLite 3 close database. Sorry, Chuck, kicked you out. All right, let's try this. Nope. Boy, there's a lot of functions here. What is this? Okay. No yos there. No yos there. There's one from me. Good. Now, oh, there's not, huh? Oh, I'm not. Where is this? YOLO. This would be where it'd be handy to have multiple functions. Here goes. Prepare. Send that. Finalize. Oh, so there should be one more finalize here. SQLite 3. Yeah. Control C. Control C. There we go. So because I wasn't finalizing it, it wasn't actually saving what I was doing, and so this delete wasn't happening, something like that, or the delete was happening, but well, let's see if we can let's see if this fixes the problem. Is there any other place where I do a prepare, but then I don't follow it with a finalize? There's prepare, finalize. Prepare, step, finalize. Prepare. Oh, if the user doesn't exist, then I need to go SQLite 3, finalize, statement. Prepare, finalize. All right, prepare, finalize. Finalize. I think that's it. Nothing. Good. Okay. It's not working. Let's send one to Barry. And it doesn't show up there. Default transaction behavior is deferred. So what I'm thinking, well, I want to see if transactions are enabled by default. Any command that changes a database will automatically start a transaction if one is not already in effect. So what I need to do is, after doing something like a delete, I need to commit. And I don't know if I have to actually send the command commit, or if there is just a function I can call to do it. I guess I actually need to do an explicit commit. Well, commit. So there's inserts, commits. There's another insert up here, isn't there? Right here. So when I started this project, so SQLite 3 is a GPL, GNU Public License database. It's not even that. It's public domain. It's one of the few pieces of software that's actually totally in the public domain. So you can do anything you want with it. And it doesn't require a server to be set up, so you don't have to have a process that's running all the time. It's very lightweight, easy to use. It's in fact the database that resides inside of your cell phones, inside of your DVR. Basically, anytime you need to store stuff in sort of a lightweight manner where you don't need a big giant service to work with, SQLite is a great database to use. It just operates on files. I didn't think that the API for it was quite so complicated. I've done C programming with the Postgres database, and it was actually easier than this. There were functions for just executing queries and getting the results back. So, I mean, we're kind of into this already, so I'm not going to back out of it. But maybe the next time I'll use a different database. Okay. Sue, okay. Nothing there. So send one to Barry, and there's none for me. There's one from Sue, and see, it's not deleting them. That is odd. Oh, whoops. Yo-yo. I've forgotten. This is Barry over here. So this is Sue. Yo-yo, Barry. See, and it's not sending one. Wait, is this is the Sue window. This is the Barry window. So it's not sending. So okay, there's already one from Sue, but it's not sending another one. So that's weird. It's only putting one in the queue. And I just get at most one. So I'm able to. Where's the sending one? Here's one sending. So we do insert into yo's from to values. Okay. And Barry's sending EO to Sue. Sue sending EO to Barry. I mean, they should be going in. And then I do the insert, prepare it, step it, finalize it, and then I do a commit. And then we do YOLO. We do a select. I think what I want to do is I want to see what ended up in the database. So let's get out of this. So only one ended up in there. This one. I'm not even sure. Well, let's do this. Let's go delete from. Let's just clear it out. And then wait. It's almost like in the time I could wait, I could set up another database. Where is it? Server programming. Here we go. The C library. You go PQ exec. You give it a connection. You give it a command. And then you can do a prepare if you want. Retrieving query information. You can get the number of fields, number of tuples, get a field number. It's almost easier. All right. He is Barry. Okay. Send one to Sue. Okay, there's one from Barry. There's still one from Barry. There are none there. That's good. And I don't see that one. So no yo. So we get out of there. So only one showed up. So what's happening is the first process that inserts into the table locks it. And then the other user is not, it can can do the insert, but it won't happen until the table gets unlocked. What is this? SQLite 3 exec. So exec could be handy for doing the, so it's just be done in place of prepare, step, and finalize. Just does it all in one. But what I really want to do is I want to make it so that, see, databases sometimes do this thing called, well, they do this thing called transactions, in which you can bundle up multiple commands like inserts and deletes. And then you can commit that transaction when you're entirely done with it, and that should unlock the tables. But for some reason, it's not unlocking the tables. So there's two solutions to it. One is to figure out how to unlock tables. The other is to put the database into what's called auto commit mode, in which the tables never lock. And you can, that's useful if you, what am I trying to say? That's useful if the statements you're executing aren't bundled up together. So like there's no dependency between them. And that's exactly what we have here. So it's not like we're inserting into two tables and we want the second insert to fail if the first one didn't work. We're really only doing an insert and a delete, and they're independent of each other. So I really want to put the database into this auto commit mode. Auto commit mode is on by default. Yeah, I want it off. I want it off. Always off. Get auto commit. Is there another one? Reset auto checkpoint, auto extension, cancel. Okay, so there's get auto commit. Where is set auto commit? Okay, so I'm going to try this here. Where's our first query database for all users? User sending, select count, star. Oh, I didn't finalize this one. So I'm going to replace this with SQLite 3 exec. Should I? The second parameter actually is a null pointer. The no, okay, okay. The third argument is not null. Okay, then is all right. The fourth argument is really the combat pointer is null. No copies ever invoked. Result rows are ignored. No, well, that's not what I want. So that's useful for doing things like a delete. All right, so prepare. Okay, step. User doesn't exist. SQLite 3. Okay, then I do an insert, prepare, step, finalize, and then commit. Prepare, step, finalize. YOLO. Select, do prepare, step, finalize, delete, prepare, step, finalize, commit, prepare, step, finalize. It's all there. Hmm. I suppose I can do something like this. Should we use SQLite 3 unlock notify? I don't know. It really should allow multiple connections to the same database. Okay. Yo. Nothing from me. There's one from me. And now that yo Barry. Hello. Ooh. All right. So the trick was to do the delete and the commit all in one. Actually, I guess that kind of makes sense because you do the delete, then you prepare your step and you finalize. And if there's no commit there, it can, in some circumstances, just throw away the delete. So let's find every place where there's something that changes the database, like here. So there was an insert here and a commit, and no selects don't need them. Delete was a commit. All right. Gotta wait. I'm getting to the point where if this works, then I'm going to consider it done enough for tomorrow. Gotta wait some more. So ultimately what I want to do is see if I can take all of these giant bodies and isolate them into their own functions. The trick is going to be passing the correct values in and out. Like each one of these needs needs the database connection. It needs I could make the database connection be a global because there is only one database connection while the process is running. Or I could just pass it around. It also needs the buffer and it needs the socket. For something like the user logging in, it needs to pass back whether they successfully logged in so that the state can be updated correctly. I suppose we could just always assume that. No, we can't assume that. Oh, it's going to be some work to get it. See, it's what I should have done is I should have just thought about this ahead of time rather than trying to jury rig it into place. No yos for me there. No yos for me there. Send some to Sue. Sue. Barry. None from Barry. That's good. Oops, I was trying to send it to Joe, but there is no Joe. Oh, there is a Joe. None from me. 2 from Sue, and now none from Sue. I think it's all working. Me is Joe, and there's one from, all right. No, right. It's looking pretty good. So some things to be done ultimately are break up into functions. Injection. But I think the rest is pretty good. I don't care about this anymore. So I'm going to probably say this is done. Yeah, as soon as I can test multiple sessions of user Barry, I think it's just going to allow it. But let's, come on. Let me in. So when you're writing your client program, I'm going to give you a big hint here. When you're writing a client program, it's going to be super important when you send your commands, like your, Yoser and yo-yos, that you make sure you send them with the new line character. If you don't send them with the new line character, then the server is just going to sit there and wait for you to type that new line character. Just like it's like if you were on the command line here and you typed yo serve and you didn't hit new enter, it's just going to sit there and wait for you to do it, and it will wait forever. So make sure when you send your commands that you include the new line character on the end of the buffer. Okay. Sue. And let's have this one here, send one to Joe. So Barry sending yo to Sue, Barry sending yo to Joe. So those happen in different windows. But we're not disallowing them from logging in more than once. And frankly, it's going to be difficult to do that. I mean, when they identify themselves, we would have to somehow mark that they were currently logged in, and then somehow unmark that they were logged in when they quit. And then what happens if they just break their connection suddenly instead of logging out correctly? And that's going to be a big pain. So we're going to allow this so they can log in more than once. Oops. So Barry sent one to Sue, Barry sent one to Joe. Yeah. All right. I'm getting tired. I'm going to call it good enough for tonight. So at least you can get started. So you kind of see how, at least from the client side, it's done. It's pretty much the same as the server. Excuse me. Do you see how the server side is done? It's pretty much the same as the client. The difference is up here. That well, first of all, this part up here is roughly the same. You still create a socket. You still bind the socket. It's just that instead of any address, you put the address of the client. But then instead of doing a connect, you do a listen. And then it's going to block here, waiting for a connection to come in. And as soon as the connection comes in, it does an accept. So there's a two-phase process there. On the client side, you just do a connect, and then it either works or it doesn't. And then you could just send and receive using the socket you were given. And the way you send and receive is roughly the same as what we've shown here. What I recommend is that you create I'm looking for it, you create this thing called buff, which is just a big character array that's going to hold what you might potentially send to the server. Do a string copy or an sprintf of what you want to send into there, and then just send it. And then to receive something, you do, where is it? Up here. Receive. And again, you give it this buffer, this maybe 1,000 character array that the network is going to put stuff into. One of the things that you can't really count on, although it'll happen with our server here, is that the network might break up a buffer into smaller pieces and then send them to you. So when you do one receive, you might actually only get part of a message, and you won't get the whole thing. That could particularly happen if the message is really, really, really long, and it has to break it up into 1,000 byte buffers. So usually the protocol has some way to indicate that the message is done. Like for getting the list of users, we got that as a dot coming out. I think what's going to happen with you is you're going to do a receive and you'll just get one username back, and you'll have to do another receive and get another username, and do another receive and get another username, and then finally you'll get a dot. Another way that could happen is you won't get one username, you'll get a whole bunch of usernames, and then you'll get the dot maybe at a separate one. So you kind of really don't know how you're going to get the data. It just comes to you. I guess the closest thing I could say is it's kind of like there's a big barrel with a spigot at the bottom of it, and the barrel is the data coming in from the network, and you open the faucet and let up to 1,000 characters out, and you close the faucet, and you might get 1,000, you might get less. You're not really sure what you're going to get. So usually the protocol has some way to indicate that it's actually done sending data, like there's some kind of marker at the end, like we got the dot. In the case of the web, it gives you a count of the number of characters that are going to be coming, and so you have to basically keep count, and then when you receive that number of characters, you know you're done receiving stuff. So network programming is not quite as deterministic as reading and writing from a file. With a file, you kind of know what you're going to get. With a network, you kind of don't know what you're going to get. You might get it one character at a time, you might get it 1,000 characters at a time. But I think that more or less the network tries to let you receive what the server sends. So if I send 50 bytes to you, you're going to receive 50 bytes. And if I send 100 bytes to you, you're going to get 100 bytes. So for the most part, this is going to work just as you think it's going to work. So I guess that's the offer I can advise right now is just go ahead and you can look at the code here and go, every time I do a send, you're probably going to do a receive. So for every one of my sends, you're going to do a receive, especially when it comes to things like the users here. See how I'm sending each user as a separate send. So if there's 10 users, you're probably going to do 10 receives. So that means you're going to have to have some kind of loop in here. You're not going to have to deal with the database at all, of course. You're just going to simply do receives until you see that dot come. So just keep receiving, and then when the buffer finally contains a dot, you know you're finished. All right. So I will see you guys tomorrow, 2 o'clock. Get some sleep. See you tomorrow.
Thanks, Barry. Appreciate it.
All right. Bye-bye.